Hi everyone, welcome to another update regarding Martian World's progress. I just want to show you something that I've been working on. We have to focus on the foundation for the game as well before we start adding a lot of the other fancy stuff that'll be a lot more fun later on. But for now, I just wanted to give an introduction to a custom octree that I've been working on. It's a way to find objects quickly, but I also wanted a multi-threaded option. So that for the sheer size of the universe, it would be nice to have multiple threads running. So let me go ahead and show you that right now. So what's going on here is that, let me pull it from a different view here. You have a bunch of these cubes, which are called nodes, and the octree has multiple nodes, and it subdivides and subdivides. When you subdivide a cube, you basically get 8 other cubes, and if you subdivide one of those cubes, you get 8 more, and so on and so forth. It's a way of separating objects into sectors. So, if I have a bunch of objects scattered throughout here, and I'm looking for a point that's over here, and I want to query, give me all the objects that are within, say, a radius of 10 from this point. I don't have to check this one, and I don't have to check this box, and I don't have to check this box. I only have to check inside of this box, right? So I can ignore all the objects that are outside of there. Now, if you do cross the boundaries, I'll have to check these 2 nodes, of course, but still it's better than checking like the entire universe to try to find objects. So that actually helps speed up the search process. Now what's going on here is that I actually have a threaded garbage collector. So I don't know if anyone's done that yet, but it actually searches through a list of registered empty nodes, and then based on a generation count decides when to dispose the node. So in this case, it's the color coding I have here visually is that anything white is generation 0, so not added that frequently. That is items that are not added to it that frequently. If it's generation 1, then it becomes a yellow color. So that means maybe 2 or 3 objects are added, but not that frequently. See here, some of these just turned a magenta, sort of a pink color. That means objects are added a lot more frequently, and then generation 2 at least. Sorry, generation 1. And so when it turns red, then it goes to a generation 3, which means it's added. I believe it goes 2 seconds. So objects added in under 2 seconds for white, under 1 second for yellow, under half a second for the magenta or pink, and under a quarter of a second for red. So if you get multiple objects added in less than a quarter of a second, it suddenly changes to a red color. That means there's a lot of objects suddenly flying through that section, and it's going to keep itself longer. If there's a lot of objects coming and going in a particular area, I don't want to keep removing and putting the node back and removing the node and putting it back and removing the node and putting it back. So the system will actually keep track of the generation of nodes and how frequently objects are there. You can actually see it happening right now. Like you can see like all the nodes here are being deleted. See that? They're all being deleted because this section is not being used. Like all of these are not being used. However, anytime I need to create a node here somewhere, I take one of these nodes that were just disposed and just pop it back into here somewhere, right? So they're recycled. All the nodes are recycled, so there's a pool that keeps the nodes, and when I need another node, it just pulls it out. And the generation allows nodes to stay a little longer. So in this case, there's this red, you see this cube here, right? Oh, there it goes. So that gets deleted. There you go. And so they're going to keep slowly being deleted because, for the ones that are not needed anymore, right? So in time, this whole box will become empty. See, there's 1 square left. Now notice the red one is still there longer because there was a lot of activity in that spot for some time, and so it's going to keep it a little longer. And there you go. Right? Now the reason why, even if I was to bring one back, it's not going to subdivide. Right? And the reason why is because you need to have at least 5 or more items in a node, and then it subdivides. Because it tries to subdivide to keep at least 5 items per node, which is customizable. I can have any number. I can have 1 or 10 or 100, whatever the case might be. Having 1 object per 1 node sometimes might make too many nodes. It just might be too memory consuming, so you may want to, and not only that, it may be somewhat inefficient to try to search through so many nodes. I believe it gets to a point when maybe you have say 10 items left in a node. It's faster to possibly search through it linearly than try to break it down through, I guess, otherwise. It might be faster to search linearly through the list for a small number of items than it is to, like for example, if I have 4 items or 8 items even, right? I still have to check 8 different cubes to find out all the items that might be, near a particular point, right? If there's like, if the radius of the search area involves intersecting 8 cubes, I still have to search through 8 cubes, right? So, if the cube itself was big enough to contain that radius, then I might as well just search through 8 objects, right? And find it that way too. So it may actually give no benefit whatsoever to a certain point. So that is customizable. And so anyways, that's, I know it's a lot of technical babble for those. I just say it for those who, are interested and actually can, might be involved with stuff like that at all. But in any case, yeah, you can see all these lines here, by the way. All these lines are showing the relationship between a particular sphere, these spheres that I have here, and these guys, and its node center. So you can see this guy is attached to that node, right? So that's all that is. So if I was to stop and restart this again, you'll be able to see, if you watch it, it actually kind of looks like spiders walking around the nodes. Let me just wait for this to refresh, and that's it. So let me keep it zoomed in here. You'll see what I mean. So see how they're connecting to the nodes they're associated with? They can be connected to up to 8 different nodes. So as they cross the node boundaries, they can be associated with 2 nodes or 3 nodes or 4 nodes. And you can see the color coding. So again, white is not that frequent. Yellow is more frequent. I believe it's under multiple objects added under 1 second. And then the pinkish color is like under half a second, I believe. Yeah, and then the red again is like multiple objects being added very rapidly, like under a quarter of a second. So like 250 milliseconds. I may have to adjust that, perhaps. I don't know. We'll see. But for now, it's been working quite nicely. It's kind of fun watching the spheres walk through. As they get associated, it's almost like they're spiders walking through a spider web. But you can see how they're associated with various nodes as they go through. When multiple objects get really close together, you can see how it subdivides, which is really cool. Yeah, so I'm just going to keep profiling this and increasing its speed and making it more and more efficient as well. But the purpose of it being multi-threaded as well is it does have multi-threaded support. I don't know if I mentioned that. So we want to have multiple threads scouring the Octree at the same time, in read-only mode, to be able to find objects that are close to other objects. And as long as it's in read-only mode, it's pretty good that way. There are, of course, going to be a lot of updates to the tree that may be required for various objects that may be challenging. I may have to split the Octree up itself in some fashion, so that there are different quadrants that don't have much to do with each other, per se. But we'll have to see how that pans out. So maybe each star could have its own, Octree or something like that. But the universe will definitely have its own Octree, right, for everything else in the universe. But maybe what I'll do is I'll have multiple stars with an Octree, and those Octrees with those stars will be tracked within another Octree or something like that. So like nested Octrees, but all operated by threads. So we'll see. I mean, there's a lot of foundational work that I have to get under, get completed first, but we'll see how it goes. Anyways, yeah, this has been fun to work on. It'll be interesting to see this actually implemented, in the final product at some point. But for now, thanks for joining me in, this journey, and make sure to subscribe and stay in touch for any future updates if you want to know the progress. Hopefully, at some point in the future, I'll have more actual, game-related footage on the progress of the game development. All right, thank you.